So let's start with section 2.2, the fractions. So first of all, we're going to start with the relation. Relation, which is in any order pair with x, y, is a relation. Any order pair with x, y, is in any point with x and y is a relation. The second part is the function. A function is a relation. So this is the first important thing. That means we have to find a relation in which x and y in which. But there's another condition. For each x has one and only one y. Each x has one and only one y. For example, if you have this is set A and set B, the function from A to B. A is an order pair of x and y, and B is an order pair with x, y. That means there's numbers here and there's numbers here. The set A is called domain, which is the input value. That means we're going to input value here with x. We're going to input the value here with x. This is the domain. And we're going to get the output from here. This is the range. This is the input, and here's the range. That means here's the function f. This one is going to be the input, and this is the output. Always the input is going to be independent variable, and the output is going to be dependent variable, which is called the range. A is called the domain, which is the input, and B is called the range, which is the output. We have one more thing, is the different quotient, which is fx plus h minus f of x over h, and always h not equal to 0. So this is just the first thing, and next part we're going to solve some examples. So if you go to the first question, they ask you a relation that sine to each element of x from a set of input. This is the input. Always, if you take from the input from the set, this is in the domain. Exactly one element to y in the set of output. The output, the y is the range. And the element, this one is called the function. A function, which is a relation sine each element, which is take each element from sine each element from x from the domain to an element from y to the range. X, y. The second question, it says for an equation that represents y to a function x, the set of all values taken on by the independent variable x, because x is always the independent variable, and variable y is always in the range, is going to be dependent variable. You see, the independent variable, which is the input, that's the x value here on the set A. The dependent variable, which means the y value on the set B, because y is always dependent on x. Like y equal 2x plus 4. This is the independent variable. This is the dependent variable. So this is independent variable, which is the x. This is dependent, which is the y. So that's the difference between x and y. This is belong to this domain, and this one belong to the range. Let's go to the third one. The third one, if the domain of the function f is not given. The domain of the function f is not given. Then the set value of independent variables, which is belong to the domain for which the expression is defined. Like if you don't have the domain, that's mean it's implied domain. Implied domain. There is no domain, so we're going to choose this one. Number 4, one of the basic definition in calculus use the ratio, which is f of x plus h minus f of x over h, which is called the quotient difference quotient. Different quotient or difference quotient. Now, let's check example 5. Example 5, They're telling you here is the X, the input X, and the output Y. Determine whether the relation represented Y as a function of X. So let's start working on this one. Example 5, we need to find Y is a function of X. If you check X, I'm going to write down X, and here is Y. X, which is 8, and Y is 3. That means 8 goes to the 3. X is 5, Y is 6. That means X goes to the 6. X is 2, and 5 goes to 12. So 2 to 9. The next one is 5 goes to 12. And the next one, 8 goes to 15. If you check that, each X here goes to 1 Y, but be careful. That's the mistakes you're going to do. You don't have to repeat the numbers again. That means you don't have to write down 8 again and 5 again. So here's 15. So 8, if you check this one, 5 goes to 12. So this is the same number, 5 goes to 12. The next one is 8 goes to 15. This is 8 and goes to 15. So in this case, we need to, like, it's a function if each X goes to 1 Y. If you check number 8 goes to 2 Y, this is the X, goes to the Y, which is 3 and 15. In this case, I just found this one. Now this is not functional, because we have to get each X goes to 1 Y. Let's, before we move to the next part, I'm going to make this one easier for you. Let's consider the X is the person and Y is the place. So this one is place and this one is the person. Well, if you have person number 1, person number 2, and person number 3, and how many places we have? Let's say this is Home Depot, this is Walmart, this is Target. If you check person number 1 goes to Home Depot. Person number 2 goes to Walmart. Person number 3 goes to Target and goes to Walmart. In this case, one person going to 2 places. So that means this is not function, because one person can't go to 2 places on the same time. But if you have, let's say, X and Y, which is the same example, person number 2, 1 and 2 and 3, and we have Home Depot and Target. So person number 1 goes to Home Depot, person number 2 goes to Target, and person number 3 goes also to Target. In this case, this is fine. 2 persons goes to 1 place, which is fine. Like hundreds of people, they're gonna go to the same place on one time. 1 person go to Home Depot, so it's fine too. So in this case, this is function. So these 2 extra examples make everything easier for you. So when you have to figure out if it's a function or no, just go ahead and grab these 2 columns and then check if it's function or no. Let's check the next example. So this one is not going to be a function. Example 5. Let's check example 6. Example 6 also the input X and here's the output. In this example, do exactly the same thing. So this is question 6. We're going to write down the X value here and the Y value here. And so -3 goes to the 3. And check the next one. 0 goes also to the 3. Check the next person. 2 goes also to the 3. Which is fine. These 3 persons go into the same place. Everything's fine. The next one is 5 goes to the same place also. So it's fine. 7 goes to the same place. So all these persons go into the same place. So in this case, this is a function because all these persons go into the same place. So we're just going to type function. That's me. We're going to choose this one. Yes, it's a function. Example 7. Example 7, let's check. They say which sets of order pair represent function from A to B. So now we have to find which function is represent a function, which one of the order pair represent a function. We have to check. Like if you look here, 3 goes to 1. 3 goes to 1 here. So this is fine. The next one, 4 goes to -2. This is also fine. 4 goes to -2. The next one, 5 goes to the 0. So this is fine. And 6 goes to 2. So this is fine too. That means in this case, this is the first option. If you check the second one, so this is the first option, this is considered a function. Let's check the second one. The second one is 3 goes to -1. This is okay. 5 goes to the 2. 5 goes to the 2. It's okay. 4 goes to the -2. Here is 4 goes to the -2. This is okay. 6 goes to the 0. 6 goes to the 0. It's okay. 4 goes to -1. 4 goes to 1 and 4 goes to -2. We have 4 goes to 2 places, which is -2 and 1. In this case, we're not going to choose this one. This one is not a function. Let's check the third one. The 3 goes to the 0. 3 goes to the 0. It's okay. 4 goes to the 0. 4 goes to the 0. It's okay. 5 goes to the 0. 5 goes to the 0. It's okay. And 6 goes to the 0. 6 goes to the 0. That means all the persons here goes to the same place, which is 0. So this is fine. This is okay. The third one, the last one, let's check this is a function or no. 3 goes to 2. This is okay. 6 goes to the 0. This is okay. 4 goes to 1. This is also okay. But what about 5? We couldn't find X goes to Y. That means X, 5, it doesn't go to anywhere. If you go back to the definition, each X has one and only one Y. That means we have to find Y for each X. In this case, for X equal 5, there is no Y. So we can't choose this one as a function. So the only two is going to be the answer for this question. Question 8. Determine whether the relation represents Y as a function of X. Let's check that. Is this a function of X or no? If you look to this example, x squared plus y squared equals 64. Before I'm doing this example, let's check a vertical line test. So if you have this graph, so to check for the graph, to check this is a function, we're just gonna graph vertical line test. Let's graph vertical line test here. You can graph more than vertical line test. And this x goes to 1y. Check another vertical line test. Let's do a vertical line test here. Also, at this x goes to 1y. That means each x goes to 1y, so this graph is a function. If you look to another graph, like this one, to check this graph is a function, let's graph a vertical line test. For this x goes to 1, 2. So we found that there's an x goes to 2y. There's a person here goes to 2 places. In this case, this is not a function. This is a function. Now let's go back to example 8. 8 it says x squared plus y squared equal 64. If you look to this one, to this example is a circle, because if you write down the general form of the circle, it says x minus h squared plus y minus k squared equal the radius squared. But this one is going to be exactly if the center is 0, 0. If the center 0, 0, this is h and this is k. So when you plug in h and k here, it's going to be x minus 0 squared plus y minus 0 squared equal radius squared. That means it's going to be x squared plus y squared equal the radius squared. So every time when you see x squared plus y squared equal a number, this is a circle. Now here we have a circle with the center 0, 0 and the radius equal 8. Because this is r squared 64, that means r equal 8. So now it's easier to graph without using calculator. So it's going to be a circle 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's a circle with the radius 8. Let's see, this is 8. Not going to be that much accurate, but it's a circle. So now I have the graph. It's easier to check it's a function or no by just graphing a vertical line text here. We found that for this x, there is 1, 2y. So that means this is not function. That's it for this question. So we're just going to choose as not a function. Let's go to the next one. Determine whatever the equations of y as a function of x. Let's check the next example. How we're going to find it's a function of x. You have two options. So question 9, the first option, you can use the vertical line test. But the equations here says x squared minus y equal 9. No, x squared minus y equals 64. Let's check this, the first option, 64. The first option, I'm going to solve these equations to the y, because always y is the dependent variable and x is the independent variable. So I'm going to solve this one to y. I'm going to just move the y to this side. So I'm going to, it's up to you how you just keep the y by itself. If you want to say minus x squared from here, this is cancelled. So it's going to be negative y equal negative x squared plus 64. Then divide by negative 1 by negative 1. So y is going to be equal x squared minus 64. Now you have two options. The first option, if you want to graph it and check it's a by using the vertical line test. So how to graph this one? So here is the function. How to graph it? You're gonna go ahead, y equal, plug in x squared. Here is the x. This is the x. So x, put down the square, minus 64. So, and hit the graph. So if you hit the graph, now check this graph. Do zoom out. Check this graph. This graph, it's exactly like this one. If you graph a vertical line test on any point, you will find out for each x goes to 1y. Each x goes to 1y. In this case, this graph is a function, because each x goes to 1y. Another part, if you want to learn how to graph this function without using calculator. I don't want to use calculator. I'm going to pick 3 points to graph the function, and you will figure out each x goes to 1y. So let's create a small table here with xy. Here is x, and I'm going to find the y. So I'm going to pick -2, 0, and 2 from the domain, because the domain for this function is all x squared minus 64. You can plug in any number, positive or negative. So -2, 0, and 2. We're going to plug in these 3 numbers to find the y. So plug in -2. So it's going to be -2 squared minus 64. So here's going to be -2 squared minus 64. That's mean 4 minus 64 is going to be -60. This is the first point, x and y. Plug in 0, so it's going to be 0 squared minus 64, which is going to be -64. Plug in 2 is going to be 2 squared minus 64 is going to be the same thing, -60. We found out the first x, -2, goes to -60, which is the y. The second x, 0, goes to 64, -64. And the third x2 goes to 60. In this case, it's okay. If you're going to keep going, -3 and 3 is going to be go to the same place. -4 and 4 is going to go to the same place, which is fine. So in this case, this is how to prove that this is a function. If you want to do the graph, it's fine. Both ways is going to be right. So this one is a function. Question 10. I'm gonna solve question 10. Again, you have 2 options to work on this one. So the first one, y equal square root of 4 minus x squared. Let's check the first option. If you graph it, if you graph this one by using the calculator, because going to clear this one. Y equal, clear this one. The square root of, this is not 4, it's 16. So question 10 is 16 minus x squared. So it's going to be the square root of 16 minus, here's the x squared. X squared. So graph it. You have to zoom in because it's really small circle. Half circle, not circle. So you see, it's a half circle. So if you graph a vertical line test here, you will see each x goes to 1 y. That means this is by the graph, we can prove that this is a function. The second method to prove that, just plot a small table and you can choose a point from the domain x, y. I can choose the point -3, 0, 3. So let's choose -3, 0, 3. Again, from the domain, you have to choose point from the domain. You're gonna learn that how to find the domain for each function. Now we're just gonna check it's a function or no. So let's plug in -3 here. So y is going to be 16 minus 9. That's means 16 minus 9 is 5. I'm going to plug in 0, so it's going to be 16. Plug in 3 is going to be also 5. That's mean -3 goes to the 5, 0 goes to 16, and the 3 goes also to 5. In this case, this is a function. That's it for this example. Let's check question. So this one is going to be a function. Let's check the next one. Y equals 7 minus absolute value of x. Let's check. This is a function or no? So question 11. It says y equals 7 minus the absolute value of x. So we're going to check that. This is a function or no? The same thing. Let's check how we're going to graph it. So we can use the vertical line test. So y equal, check here, 7 minus, how we're going to write down the absolute value of x? You're going to click on math. Going to click on math. Here's the math. NUM, the numbers. The first one says ABS. ABS. Click on this one. Is going to be the 2 line, which is the absolute value. Now we're going to put down the x. And let's check. Graph it. Check the graph. The graph is flipped over x-axis. So if you graph any vertical line test here, or here, or here, you'll find each x goes to 1 y. In this case, we can say that this graph is a function by using the vertical line test. Let's graph it without using vertical line test. Let's create a small table, x, and to find the y. So I'm going to choose -4. I can choose -1, 0, 1, 4. This one I choose more than 1 point, and let's plug in these points in the function. So plug in -4 here. The absolute value of -4 is going to be 4. So 7 minus 4 is going to be 3. That means the first y value is a 3. Plug in -1. So the absolute value of -1 is going to be 1. That means 7 minus 1 is going to be 6. Plug in 0, the absolute value of 0, 0. 7 minus 0 is going to be 7. Plug in 1, it's going to be the same thing. The absolute value of 1 is going to be 1. 7 minus 1 is going to be 6. Plug in 4, the absolute value of 4 is going to be 4. 7 minus 4 is going to be 3. So let's check these numbers. We did the table. We found that x, y, -4 goes to 3, which is okay. -1 goes to the 6, which is okay. 0 goes to the 7, which is okay too. Now 1 goes to 6. That's fine. 2 persons going to the same place. We found that 4 going to 3. That means 4 going to the 3. So this one is also fine. 2 persons, -4 and 4 going to the same place. So this is, we can prove that this is fraction. So here's another 2 ways to find it's a fraction or not. By graphing the vertical line test, also it's going to be like the easier way to figure out it's a fraction or no. So this one's going to be a fraction. Let's go to the next one. Now we have the absolute value of y equal 4 minus x. This is a little bit different. Let's work on this one. Because you can't graph this one. You can't graph the absolute value of what y equal, because when you click on y equal, you can't plug in the absolute value of y here. So let's check how we're going to work on this one. This example, it says the absolute value of y equal 4 minus x. Now, we already know the absolute value of any number, we can plug in negative and we can plug in the positive one. Because you're going to plug in the negative number here, the result is going to be positive. You can plug in the positive number here, the result is going to be positive. So in this case, the absolute value of y, 2 parts. The first part, this is important, this example is really important. And there is the second. I can use the negative y here equal 4 minus x. And I can use the positive y here equal 4 minus x. Let's solve this one for the y. So y is going to be, you can divide both sides by negative. Or if you want to just keep it like this, let's solve it for y, to keep the y here by itself. Like I'm going to divide by -1, and divide this one by -1. So y is going to be equal 4 divided by -1 is going to be -4 plus x. Because negative x divided by -1 is going to be positive x. That's me plus x. On this side, it's going to be the same thing. Y equal 4 minus x. It's already solved. Now I'm going to work on this one and check. Let's choose any number. X, any number. Let's choose x equal 5. X equal 5. This is the input. Plug in 5 here. Y is going to be equal 4 minus 5. That means y is going to be equal -1. This is the first value, which is the first value for this function. Let's plug in 5 on the second part, because this function has 2 parts. Plug in 5 on this one. That means y is going to be -4 plus 5. In this case, y is going to be equal 1. That means for x equal 5, we found 2 values. Here is the x and here is the y. X equal 5 is going to be -1 and is going to be 1. This person going to 2 places. This person going to 2 places. X, when you plug in x, here on this side, it's going to be -1. When you plug in x equal 5 on this side, it's going to be 1. -1 and 1, this is not a fraction. You can choose any number. So this one is not a fraction. That's it for this example. This example is really important. So we're just going to choose no. I'll leave this one for you. If you have y equal -85, check that. Is this a fraction or no? What about this one? There's no y here. It's just the x equal 1. There's no y, so we can't consider this is a function. So we're just going to say this is not a function. The next part of this section, how we're going to find the value of the function. Let's check this example. Find the function value. F of x equal 3x minus 6. Let's find the value of this function. Question 15. F of x equal 3x minus 6. 3x minus 6. We need to find f to the 1. That means this is the input 1. X equal 1. I'm going to plug in here. So it's going to be 3 times 1 minus 6. 3 times 1 is going to be 1, minus 6 is going to be -3. So the first result is going to be -3. Now I need to find f to the -2. F to the -2. So I'm going to plug in -2. That means it's going to be 3 times -2 minus 6. 3 times -2 is going to be -6, minus 6 is going to be -12. This is the second one. Now, the third one, I need to find f x plus 4. Look, well, this is really important. You're going to plug in instead of this x plus 4. So be careful. In this x, you're going to plug in x plus 4. So that means it's going to be 3. And this x, I'm going to plug in x plus 4 minus 6. Now I need to simplify this one. That means you're going to distribute here. So it's going to be 3 times x is going to be 3x. 3 times 4 is going to be 12. And minus 6. And the result is going to be 3x plus 6. Because you can combine these together. That's it for this example. Let's keep going. So we're just going to plug in here. -3, and here -12, and here we're going to say 3x plus 6. That's it for this equation. To the next one, let me solve this one. This one is exactly the same. And I'm going to solve this one. So let's solve example 16. Question 16. We just have different type of equations. So question 16. We have g over t equal. Now, the independent variable is t and g over t. So 4t squared minus 5t plus 5. So now let's find the first one, g over 2. The first one, g of 2. That means we're going to plug in instead of each t, number 2. So it's going to be 4 parentheses 2 squared minus 5 parentheses 2 plus 5. Let's check that. It's easier because you're going to do mistakes here. So 4 parentheses 2 squared minus 5 parentheses 2 close the parentheses, plus 5. Enter, so the result is going to be 11. So I'm going to write down this is equal 11. Now we're going to find the next one, g t minus 2. T minus 2. T minus 2. That means instead of each t, I'm going to like t minus 2. So this one is going to be 4. Now t minus 2 squared minus 5. T minus 2 plus 5. Now this is a little bit different because we have to simplify this one. We have to simplify this one. So before I'm going to the next part, how are we going to simplify these two parentheses? So I'm going to write down t minus 2 and t minus 2 here on the side. T times t is going to be t squared. T times negative 2, I'm distributing because this one, t minus t squared is going to be 2 parentheses. So t times t squared, t times negative 2 is negative 2t, negative 2 times t is negative 2t, and negative 2 times negative 2 is going to be plus 4. Combine the like terms, so it's going to be t squared minus 4t plus 4. So I'm going to write down everything here instead of t minus 2 squared. That means this one is going to be equal 4 t squared minus 4t plus 4 minus 5 t minus 2. I'm not going to distribute. I'm going to distribute next step. 5 t minus 2 and plus 5. Now I'm going to distribute here. So it's going to be 4 t squared minus 16t plus 16 minus 5t plus 10, because negative 5 times t, negative 5t, negative 5 times negative 2 is going to be positive 10 plus 5. So now, the next step, you just have to combine the like terms, which is 4t squared is going to be by itself. Now, negative 16 minus 5, that's it. This negative 16 minus 5 is going to be negative 21 t. And 16 plus 10 is going to be 26, plus 5 is going to be 31, plus 31. So this is the result of gt minus 2. Now the next step, we need to find, they ask you find g of t they ask you g of t minus g of 2. Let's check that, because we already have g of t, which is this equation. So 4t squared minus 5t plus 5 minus g of 2, which is the 11. So minus, here is g of 2, which is 11. That means this one is going to be 4t squared minus 5t plus 5 minus 11. And the result is going to be 4t squared minus 5t minus 6. That's it. This is for the third one. So g of 2 is going to be 11. And gt minus 2 is going to be 4t squared. This is the squared, be careful. Minus 21t, so minus 21t And the next one is going to be plus 31. So plus 31. And the result, when you say g of t minus g of 2, is going to be 4t. This is the squared. Go down. Minus 5t minus 5t minus 6. Minus 6. That's it for this question. The same thing for example 17. You can do exactly the same steps, but be careful you have here square root. And for example 18, you have quotient q of x 1 over x squared minus 9. Let's check how we're gonna solve this one. So question 18, we have q of x equal, it's the q, not 9, of x 1 over x squared minus 9. We need to find the q to the 0. So q to the 0 is going to be 1 over 0 squared minus 9. And the result is going to be negative 1 over 9. Just going to keep this one, 1 over 9. Next part, we're going to plug in 3. Q of 3. B, it says find Q of 3. So it's going to be 1 over 3 squared minus 9, which is going to be 1 over 9 minus 9. That's going to be 1 over 0, which is undefined. That means this is undefined because you can divide any number by 0. So you can choose undefined. I think you have to type it because this one is going to be fraction. This one, you have to type it undefined, okay? Undefined. So you're going to type undefined. This one is going to be a fraction, which is, you can say negative 1 over 9. It's going to be right, or you can put the negative in the front. It doesn't matter. C is going to be qy plus 3. We need to find the q of y plus 3. Y plus 3. That's mean instead of each x, we're going to put y plus 3. So it's going to be 1 over y plus 3 squared minus 9. So the same thing here, you have to find y plus 3 and y plus 3 on the side. So y times y is going to be y squared, y times 3, so it's going to be plus 3y, again plus 3y, plus 9. Combine the last terms, so it's going to be y squared plus 6y plus 9. So let's go back here, and this one is going to be equal 1 over y squared plus 6y plus 9 minus 9. So this one cancel with this one, so the result is going to be 1 over y squared plus 6y. That's it. This is the result for question 18C. So you can type here. It's going to be fraction 1 over y squared. This is y squared and plus 6y plus 6y. That's it for this question. Question 19, it's the piecewise function. Piecewise function is the function with two pieces. Like for this one, you see, f of x equals 4x plus 1, 4x plus 5. So this is the second case. So question 19, f of x equal 4x plus 1 when x less than 0. That's be negative numbers. Here 4x plus 5 when x greater than or equal 0. They ask you to find f to the negative 1. Negative 1x is negative, that's mean on the first piece. So we're going to plug in negative 1 in the first one. 4 times negative 1 plus 1, and it's going to be negative 4 plus 1 is going to be negative 3. The second one, we need to find f to the 0. So 0, here's the equal sign, that's mean belong to the second piece. So we're going to plug in 4 times 0 plus 1, and it's going to be equal 1. Sorry, to the second one, so plus 5. So the result is going to be 5. The third one, they ask you to find f to the 2. 2 is belong to the second one, because x is greater than or equal 0. That's mean 0, 1, 2, 3, 4. So we're going to plug in the second piece. So it's going to be 4 times 2 plus 5. And 4 times 2 is going to be 8. 8 plus 5 is going to be 13. That's it for this example. So we're going to type here negative 3, 5, and 13. That's it for this example. Next example, you're going to do exactly the same thing. Another 20. Now be careful. For this one, we have f of x is 2 pieces. The first piece is negative 4x plus 4 or minus 4 when x is less than 1, x less than negative 1. And the second piece is x squared plus 2x minus 1 when x is greater than or equal to negative 1. They ask you to find f to the negative 3. So negative 3 is belong to the first piece because x less than negative 1, which is negative 2, negative 3, negative 4, and keep going. So this one belongs to the first piece. So I'm going to say negative 4 times negative 3 minus 4, which is equal to 12 minus 4, and this one equal 8. To the second one, find f to the negative 1, which is equal. Negative 1, here is the equal sign, so belong to this piece. So it's going to be negative 1 squared plus 2 times negative 1 minus 1, which is equal 1 minus 2 minus 1, and this one equal negative 2. Because this is negative 1 minus 1 is going to be negative 2. The third one, find f to the 1. 1 belong to this piece also, because all the numbers are greater than negative 1, which is 0, 1, 2, and keep going. So this one is going to be 1 squared plus 2 times 1 minus 1. And the result is going to be 1 plus 2 minus 1. And the result is going to be 2. Check the difference between these two examples. That's it for this question.